Bismillahirrahmanirrahim.
Assalamu alaikum, dear ones. Hope so you all are fine by the grace of Allah Almighty. Students, in our previous lecture, we have completed question number 5, 6, and 7 of exercise 1D, which was about relationship between the sets and missing letters related to equal and equivalent set. In today's lecture, we will study some more new concepts which are proper subset, improper subset, superset, set, cardinality, and one-to-one corresponding. So let's take a review of set and subset. Students, here is the definition of set. You can see that set is a collection of well-defined distinct objects, as I explained this definition in first lecture. Well-defined means a specific property by which we can easily identify whether or not an object belongs to the given set. And distinct object means different from the objects in this set. Next one is about subset. As we know that subset means in a set there is another set present which is also a part of that set. Here is the definition of subset, which is suppose A is any set and every element of set A is element of set B. Then set A is called subset of B, which means that all the elements of set A are present in the set B, but we don't know whether every element of B is also an element of A. Let's take an example which is given. A is equal to the set 5, 10 and B is equal to the set 5, 10 and 20. You can see that all the elements of set A are present in the set B, which shows that A is a subset of B. Let's move towards proper subset. Proper subset means if all the elements of set A are present in the set B, but at least one element of set B which is not present in the set A. So it may be 2, 3 and 4 elements of set B which may not be present in the set A. Then set A is called proper subset of B. Here is the definition given, which is set A is called proper subset of B if every element of set A is element of set B, but there is at least one element of set B is not present in set A. Here is an example, which is A is equal to the set 1, 2, 3 and B is equal to the set 1, 2, 3, 4 and 5. You can see that all the elements of set A are present in the set B, but in set B there are two elements which are not present in the set A, so we can say that A is a proper subset of B. Let's move towards improper subset and let's see an example to understand the concept of improper subset. Example is the set E is equal to 1, 2, 3 and F is equal to 3, 2, 1. Here we can see that each element of set E is present in the set F, which means that E is a subset of F. But here all the elements of set F are also present in the set E, which means that E is an improper subset of F. Students, let's take a review. In a subset, all the elements of set A are present in the set B, but it doesn't matter, either all the elements of set B are also present in the set A. Second one is proper subset. In proper subset, all the elements of set A are present in the set B, but at least one element should be which is not present in the set A. Third one, improper subset. Improper subset is that in which all the elements of set A are present in the set B, which is called A is a subset of B. But all the elements of set B are also present in the set A. Students, next one is superset. In superset, all the elements of set B are present in the set A, which means that B is a subset of A. Then the set A will be called superset of set B. Here is the definition given, which is if B is a subset of A, then A is a superset of B. We can write it as A is a superset of B. This symbol is used to represent superset and is read as A is a superset of B. Students, in the given diagram, which shows that All the elements of set B are also present in the set A, which means set B is a subset of A. Then set A will be called superset of set B. We will be write it as A is a superset of B like this. Let's see an example to understand the concept of superset. Students, you can see that here is a set A and B, and all the elements of set A are present in the set B, which means that A is a subset of B. And then set B will be called superset of set A. Let's move towards the next concept, which is about power set. Students, in a set, all the subsets of the given set is called power set. Here is the definition of power set, that is, if A is a set, the power set of A is the set of all subsets of A denoted by P of A is equal to the set all X such that X is subset of A. Now the question is, how many subsets of a set has? By using this formula, we can find out the subsets in a set. Let's see an example which is mentioned below. Example number one is, what is the power set of O, which is equal to A, B, C. We can count the number of elements here are 3 by putting the value of n is equal to 3 in the formula 2 raised to power n. So it would become 8. 2 raised to power 3 would become 8, which means that in the given set, the subsets will be 8. One-to-one correspondence and equivalent set. One-to-one correspondence means a pairing in which each element of one set corresponding to the other element of second set. You can see here is a definition of one-to-one correspondence and equivalent set. We are already familiar from the equivalent set. Let's move towards the definition. A one-to-one correspondence between two sets is a pairing where each element of one set is paired with exactly one element of the second set, and each element of the second set is paired with exactly one element of the first set. It means each element of the first set and each element of the second set corresponding to each other. We know that in equivalent set there is also one-to-one correspondence. Here is an example of one-to-one correspondence. You can see that two sets are given. In the above set, the elements are A, B, C, D, and in below set, the elements are 3, 7, 9, 11. And we can see that the element of set above given is A, which is corresponding to the first element of the second set. Similarly, you can see that in the above set, element B is corresponding to the second set of the second element, which is 7. And so on, C corresponding to the 9 and D corresponding to this 11 element. Here is no any element which is not corresponding to another element of the other set. That is all about one-to-one correspondence. Now let's move towards cardinality. Students, we know that in a set there are number of elements present. The number of elements which are present in our sets is called cardinality. Here is the definition given. You can see that cardinality refers to the number of elements in a given set. It is denoted by the symbol n. Cardinality of set is written as n of A. Let's see an example which is given below. A set A is equal to a set of primary colors which are selected yellow, red and blue. The number of elements present in this set are 3, which are represented just in front of the example, which is n of A is equal to 3. Students, the number n represent cardinality. Let's move towards another example, which is B is equal to school days in a week. That are selected Monday, Tuesday, Wednesday, Thursday and Friday. We can count the number of elements are 1, 2, 3, 4 and 5. So n of B is equal to 5. The number n represent cardinality. We can also use the word cardinality instead of number of elements in a set. Let's see the symbols to represent these all. Now symbols used in the sets are given. First one is, the symbol is given and its meaning is equal to. Example is also given to understand the concept equals to, which is 1, 2, 5 equals to 5, 1, 2. We can see the elements of first set is equal to the elements of second set, which shows that both sets are equal. and we use this symbol. Second one symbol is also mentioned here, which means that not equal to, and the example is 1 to 5 is not equal to 1 to 4. This symbol is used to represent is not equal to. Third one meaning is are equivalent sets. So example is also given, set x, y, z and 1, 2, 3. We can see that both of these sets are equal as the number of elements in both sets are same, which is 3. So this symbol is used to represent equivalent set. Students, fourth one is a member of, and the example is 3 is a member of the set 1, 2, 3. As you can see that in this set 3 is also a member. Use this symbol to represent a member of. Fifth one symbol is not a member of. You can see in the example that 3 is not a member of the set 0, 1, 2, and we use this symbol to represent not a member of. Next one is the symbol is empty set or the null set. Students, in the example you can see that a set is represented, but in this set there is no any element, so it is called empty set or null set, which has no element. We use this symbol to represent empty set. Seventh point is a subset of. So in an example you can see that A is equal to the set 1, 2, 3, B is equal to 1, 2, 3. All the elements of set B are also present in the set A, so we can say that B is a subset of A and use this symbol. Next one is a proper subset of. In the example you can see that A is equal to 2, 3, 4 and B is equal to 3, 4. All the elements of set B are present in the set A, which shows that B is a subset of A. But if we can see that at least one element of set A is that is 2, which is not present in the set B, which make it B is a proper subset of A. And the last one is that the symbol is used to represent such that. Example is all x such that x is a day of days of week. We use this symbol to represent such that. Hope so students you all clearly understood today's lecture, and there will be no difficulty to understand these all concepts. Just make your interest and develop your interest, and you will feel easy to understand these all concepts. Learn these all definitions and also understood these all concepts. Okay, best of luck. Thank you. Allah Hafiz.